This is in the next section, but the problems are very similar to previous ones. Here I just have to invert everything. Nothing's changed except I've got a natural log in here instead of a common log for a couple of these problems. So for example, in the first one, just swap the input and the output. So this is the common log, that's base 10, so 2 to the n is equal to 35. Okay, how about the next one? Natural log of 75 equals x. Swap it. Natural log means base e. So you say e to the x is equal to 75. It's easy. How about this one? The natural log of x is equal to 3/4. It's the same as before. E to the 3/4 equals x. And how about the last one? The natural log of n over n sub 0 is equal to minus kt. Flop them around, you get e to the minus kt is equal to n over n sub 0, which is exactly the expression, for example, for exponential decay. If I write it like this, that's the exponential decay equation where k is positive. Okay? All right. More of the same. Remember what we have to swap with. Swap the input and the output, change to the inverse function. So here we have base 10, so we're going to use the common log, not the natural log. So what are we going to say? This is the output. We're going to say the log base 10 of n is equal to minus t over c. How about the next one? What are we going to do with this guy right here? I suggest bringing it over here first. I over I sub 0 is equal to e to the minus kx. So you get what? The natural log of I over I sub 0 is minus k over x. Alright, remember natural log because it was base e. How about this one right here? Put it in logarithmic form. How are you going to do that? The natural log of 27 is is 3x. Natural log of 27 is 3x. Okay? Count powers of the base. Yes? Okay, and then the last one. A half is equal to e to the minus kt. So it's the natural log again because of base e. So the natural log of a half is minus kt. Remember, output, input, now input to the log function, output. Okay, next problem, 61, not too hard either. I've already written them backwards for you, and this just needs to go into your calculator. So you need to take the natural log of 1.0253. How do you take the natural log in your calculator? The natural log is right here, the natural log button. So just take the natural log of 1.0. What was the number again? 253. And you're done. Okay, so you can do the rest on your own. Notice before you finish this, after you take the natural log of 3, you'll need to divide by a half. After you take the natural log of a half, you'll need to divide by 3 in order to find the value of the variables indicated. Okay, here we go with 62. You're only asked to do the first one. So what if you switch it around? What would you get? You get e to the 1, because it's natural log, is equal to 3x. Of course, then you're going to have to take e and divide by 3. So how do you do that in your calculator? You do second e, which is down here. Okay, and then you put a 1 in to get to the first power, and then you're going to divide by 3. So there's the answer. 0.906. 0.906. You can do these others. They're not too hard. What if I bring the 3 down here below, 5/3, and then I switch it around? I get e to the 5/3 is equal to x. Notice how if I do 5 divided by 3 in a parenthesis, I can do it just like that. Really easy. E to the 5/3. Okay? This one requires this little rule to put logs together. So the sum of logs is the product. So I take the log of 3x is equal to 1.53 times x, right? and then I swip it around, and I get e to the 1.5 is 3x, so I got to divide that by 3. So I put that in my calculator, come up with a number.